Right, today's lesson is about slope. You've probably seen slope in Algebra 1. We need it for the next couple of sections in geometry, so we need to know what slope is and how we can find it. Slope is the rate of change a line is going through. A lot of times we hear this thing called rise over run, right? Meaning if we're looking at a line going from left to right, is our line going up at a certain amount and over at a certain amount, or is it going down a certain amount and over a certain amount? That's what we're talking about when we say rise over run. And another way that we can think of that is the change in y, meaning the y-axis, over the change in x, meaning the x-axis. So how much different would it be from one position on the line getting to another? We would look at the rise over the run, or the change in y over the change in x. Now, there's a formula for this, and it has to do with the coordinates of a specific line. Remember, we were talking about the change in y. So if we notice that we have two specific xy coordinates, we can use that to figure out how much they have changed over this specific distance. And seeing as slope is a constant for a line, it's going to give us a slope for the entire line, not just this distance, but the entire thing. So, in math, when we hear the word change, we generally think about subtraction. We want to start looking at our endpoint and subtract away our beginning point, and that's going to give us the change that y went through. So we think about this as y2 minus y1. And again, for change in x, we're looking at how much different it is between x2 and x1, where we started and where we ended. So we're going to take x2, our end point, and subtract away x1. This is the slope formula. Memorize this if you need to. If you can't remember it based off of this, then just memorize it. Okay? This is going to give us the slope of a line guaranteed if we have two coordinates. Now, another thing that you might remember from algebra from last year is the y-intercept form of a line. Well, here it is. Here's our y value, right? If we plug in some unknown amount into this formula, it's going to go through this function and we're going to get a y value out. And that's how we're going to graph the particular line. But we have these little pieces that really are useful for us. One piece that we talk about is the y-intercept. That's this b value. That's really just telling us where our particular line or graph is going to start on the y-axis. So that's useful information for us to know. The second piece that we want, and that we're mostly concerned with today, is slope, which is the m value. This is useful for us. We're going to see it mostly in terms of a fraction, okay? And when we think about fractions, we're going to think about this whole rise over run. It's how much up or down and how much left right the particular line is going to go. So we're going to be paying attention a lot to this m value. Now there's three types of problems that we're going to be looking at that involve finding slope. The first is going to be based off of the y-intercept form of a line. Now, if we look right now, this definitely is not the y-intercept form. We need it to be in this form, y equals mx plus b. And we don't have that right now, but we can do some algebra to get it to look like that. Think about what we need. We want y to be by itself. Right now, y has this 9x attached to it, and it also has this -3. So we need to somehow get this 9x to move over, and we've got to get rid of this -3 somehow. Well, algebra takes care of that for us. Here, we want to subtract 9x from both sides. That'll eliminate 9x from this side. We'll have -3y equals -9x plus 18. Nothing's happened to the 18 yet. And to get rid of this -3y, and the -3 attached to the y, we're going to divide by -3 on both sides. That gets rid of my -3 here. I have the y that I want, right? Just plain old y, just like we set up here. Here I notice I have negative divided by negative, so I know I'm going to have a positive result. 9 divided by 3 is going to give us 3 over 1 x, and then I have 18 divided by negative 3, that's going to give me negative 6. Now, I know 3 over 1 is really just 3. I'm going to leave it as 3 over 1, because if I was to graph this, I know, looking at it, that I want to go up 3 and over to the right 1. So I'm going to keep it in the fraction form. Is it wrong if you have it as a whole number? No, it's not wrong, but to me, it's a little bit easier to keep it in that form. So our slope for this particular line is 3 over 1. I have a second problem set up for you. If you want to take a second to pause it and see if you can come up with the correct slope for this line, take a second right now, pause it, try it. Alright, let's see how you did. We want to get y by itself, and I notice I have negative 5x, so I'm going to add 5x to both sides of my equation. That eliminates those here. I'm left with 4y equals 5x plus 12. Nothing's happened to the 12 yet. To get rid of that 4, I'm going to divide everything by 4. That leaves me with y equals 5 over 4x. 12 divided by 4 is positive 3. But we're only concerned with the slope at the moment, and that happens to be 5 over 4 for this particular problem. How'd you do? I'm sure that you guys are going to get this. Alright, the next type that we can look at is finding slope through given points. Now, we had this formula up here, and it tells us that it doesn't matter what x, y coordinates we have. If we have two coordinate pairs, we can plug it into the formula and figure out the slope of that particular line. So let's take a look at this example that we have here. They tell us to find the slope of line containing points A and B. Now listen, I've been doing this for a good amount of time in my life, and I still take the time to write down x1, y1 and x2, y2 on my coordinates. It took me maybe an extra 3 seconds to do, but it's going to save me a lot of misery later, because all I have to do is make sure that I plug in the correct coordinates into my formula now. I don't have to think about which one goes where. Okay? So, our formula says y2, which right now is 3, minus y1, which is 6, over x2 happens to be another 6, minus x1, which is negative 1. Now, I like writing it out completely like this because I get to notice little things like double negatives. When we see double negatives, we should be thinking plus, right? Minus a negative is really like addition. So I like writing it out so I can see things like that. All right. 3 minus 6 is going to give me negative 3. And 6 plus 1 is going to give me 7. So the slope for this line is negative 3 over 7. Let's see if you can try this one on your own. This one says, find the slope containing points J, 3, 1, and K, negative 3, negative 2. Pause the video, try that one out on your own, and then come back and see how you did. Alright, let's see how you did with this one. Again, I take my time to put x1, y1, x2, y2. It doesn't really matter which one's x1 and y1, x2, y2. You could have switched these if you wanted to. The important thing is that we want to make sure that we're using the right coordinates in the right order. We don't want to switch by accident. So that's why I make sure to label these. So y2 is negative 2 minus y1, which is positive 1. x2 is negative 3 minus x1, which is positive 3. So I have negative 2 minus 1 gives me negative 3. Negative 3 minus 3 is negative 6. I'm going to reduce every time I do these problems to the lowest terms. One thing I should notice right now is I have double negatives. These are going to eliminate each other, making this whole thing positive. And I notice I have 3 over 6, which is the same thing as 1/2. So this reduces to 1/2. Our slope for that particular line is 1/2. All right. One final type of problem that we're going to look at is finding the slope of a given line when it's already graphed for us. Now there's 2 ways we could do this. We should notice that they give us specific points. We know how to find coordinates. This looks like it's -4, +3. This looks like it's 1, 1. We can plug that into the slope formula. It works. It's going to give you the correct slope. However, we don't have to take the time to do that. We can just use a counting method. We know that we're talking about how much up and down, which would be our rise, and we know that we're talking about how much left and right we have to go, which would be the run. So all we really have to do is just count. Just be mindful of the units. These are all 1 unit apiece, so when I count, it's going to count as 1, 2. Okay? So what I'm looking to do is I want to figure out how far down I have to go. Remember, I'm going from left to right, so how far down I have to go to meet this point. It looks like I'm going 2 down. Now, that's important because I'm heading in the negative direction, so I want to be sure to include that negative sign. And from here, I know it's always going to be positive because I'm going from left to right, so I just have to count the units. This is 1, 2, 3, 4, 5. So the slope for this particular line is -2 over 5. That's the slope. Try this problem on your own. Take a second to pause it. You might be able to do this one right on your screen. Alright, let's see how you did with this one. Remember, we're always counting from left to right. So I'm going to look from this point up to this point. I'm doing this by the counting method. If you happen to have done it by slope formula, you're going to hopefully see that you get the same result. So here we go. Going from left to right, I'm going up. So that's positive. How much up am I going? 1, 2, 3, 4, 5, 6, 7. So I went positive 7, and I'm going positive 2 in the x direction. So the slope for this line is 7 over 2. That's as simple as these problems get, guys. Slope formula works really well. Counting method works really well if you have a good enough graph. And if you put it in the y-intercept form, the slope is right in front of you as that m value. Practice these, guys, because this stuff is going to show up in the next couple of lessons when we start talking about parallel and perpendicular lines.